I'd like to introduce you to Dr. Daniel Zegarra-Ruiz, who comes to us from the lab of Gretchen Deal. And he's going to take us on a fairy tale from the gut to the thymus, a microbe's tale.
Okay, we're walking ecosystems inhabited by trillions of bacteria that coexist and evolve with us. These microbes are found pretty much everywhere in our body, but predominantly in the gut. And for us to live in harmony, they need to interact with the immune system. This is done through T cells, which can specifically recognize these microbes and decide their fate. Until recently, it wasn't known where these microbe-specific T cells were coming from, but now we have figured out where these cells are generated. To better explain this, let me tell you a story, a love story between a microbe from the gut kingdom, a prince, if you will, and a princess, a T cell that lives and grows in the thymus castle far, far away from the gut. The prince microbe is eager to meet the princess, but for this, he needs to find his noble steed, or actually, the noble steed, a dendritic cell from the gut, needs to find him. The prince microbe hopes on the noble dendritic cell steed, and together they embark on an adventure from the gut to the thymus. The journey takes a couple of days, but eventually they make it there. In the thymus, prince and princess meet each other. They hold hands, and the DNA receptor encounter. Their union was meant to be. And together, they have a large progeny, a couple hundred kids. And these new microbe-specific T cells are going to recognize specifically their respective bacteria. As these microbe-specific T cells mature and become well-educated, they're going to be ready to migrate away from the thymus and go everywhere in our body, including the gut, where they can meet their own prince, hold hands, and react accordingly. And these unions are critical for the host well-being because they're going to help protect the gut kingdom against pathogenic enemies. Although a happily ever after occurs when the protagonists of our story are young, as time passes, the noble dendritic cell steed can no longer make it to the thymus. Prince and princess never meet, and new microbe-specific T cells cannot be generated. However, older cells deserve love too. And to help them out, we were able to hack this process and restart it in older hosts by manipulating their microbial communities. Whether these new unions between older cells is going to be beneficial or detrimental to the host remains to be seen, and it's something that we're actively studying because multiple diseases can be exacerbated by T cells overreacting against gut microbes. Overall, understanding how these microbe-specific T cells are generated is going to be critical for the development of new therapies against inflammatory disorders and autoimmune diseases. Thank you.